They didn't eat anything, Pavana. Come on. Oh shit, you want chapter?
Yeah, I'm on chapter.
Hey, so it.
I'm like a solid. A dessert.
Yeah.
Oh shit, sorry.
Lava cake with ice cream on top of it.
Shit. Sorry, Arch. I'm literally trying
No, I haven't started.
Wait, start what?
I'll start tomorrow.
Wait, start
Data visualization.
What?
Concept was easy.
90%.
Wait, what?
Oh.
Wait, what happened with the data mining?
Wait, you said data viz.
So far, it's 90%
You know what?
response.
You talk about one topic at a time. You're already going
What can I do to help?
Yeah, exactly.
Just give me something to do and I will do it.
Wait, what did I do?
Wait, do you need the project or your specific part of the project? I will literally do our group data viz project. I will do for you.
Is what I did wrong, right?
Okay, you can see what I should do with that.
Yeah.
I'm kind of going
Well, we made part one to submit, right? And I did part one and I put it on the yeah. Well, no, I submitted the map level. I didn't put the level. Because you needed to submit the map level. I've definitely done it for I don't want
So we didn't get enough time to discuss the project, right? So there's a lot of questions which I couldn't answer in class, and I answered emails as far as possible. But let's discuss the project today. Now I did extend the deadline, right? When is it now? What? Let's do it 19. Let's do it 19 and then let me explain some things and then you can just do it very fast. So I thought that, so this is a big class, but what I try to do is my assignments, in every class I try to do this, the assignments are not like programming projects. I try to have assignments as a research task where you apply your thinking and will come up with new solutions. But often that doesn't work because this huge class, a lot of people are just want to get done with the assignment. Right? So it doesn't work. So the problem with that is I don't have the right answer. Right? If I don't have the right answer, I don't know what to tell you. Right? So I hope that you will apply some thought and come up with an answer that may be right. So if you put an honest effort and if you can write logically your report, then you should get an A in the project. Doesn't matter whether your code is right, code is wrong. Right? A code, everybody's code is right. MATLAB is so easy, it doesn't matter. And to check the correctness of code is nothing. I just hit F5 and it gives me results. So coding is not big deal. But I wanted you to come up with these ideas. So whatever I will discuss now, that is just one way to do the assignment. There are 10 ways to do the assignment. Okay? So you don't have to follow my way. You do it your way, but you explain it properly, logically. So a part of that logical we'll discuss logical explanation in detail. Technical writing, you have to also write it in a better way. I will discuss that later. But one form of logical writing that is essential, that you have to understand. And this problem, the lack of understanding of that, I saw it in maybe more than 60% of the projects last semester. And I am seeing it in nearly all the people that are coming, all the students that are coming to me to discuss. I am seeing that in all of them. The flaw is graphs without labels. You show me graphs, no y-axis, no x-axis. How am I supposed to know? What is that line even supposed to mean? How did you get this graph? So there is a saying that a picture means 1,000 words. Right? Picture is equivalent to 1,000 words. But they don't say the underlying fact that a picture with a caption is 1,000 words. And that caption takes up maybe 100 words. Right? So picture without a caption is nothing, 0 words. Right? So that is one of the biggest flaw everybody has. So make sure you have access and legend. If you don't have access and legend, I won't even see what you have written. Total 0. Right? So you have to do that. But let's discuss my way of thinking of how you can do the assignment. You don't have to follow it. If you have done some other way, do it. I encourage that. I would appreciate if you do it some other way. Right? If you follow my way, I will appreciate you less. But that doesn't mean that you won't get the points. Who cares for appreciation? Everybody cares for points. So the first step is not required to do, but it is good to do. It's good to do because you now get an idea of how the data looks like. So first step is basically, it's not required for the entire project to work. If you have skipped the first step, no big deal. But it is good for you to do in order to understand the data. Okay? So first step says is you organize the data. How do you organize? Now in there you will have to clean and do all those things, but we'll come to that later. So first step is you organize the data. So what I said is, okay, have some separate CSV or XLS, whatever files, each for a gesture, say about, right? Or maybe some other gesture. So let's say about is gesture. Now each gesture, each individual has 20 actions of the same gesture, right? Each individual. I am not focused. I am very focused. Okay, now I am focused. Now focus is off. So, okay, you have 20 actions per individual. Now, one student came and, one group, not a student. So, one group came and said that, okay, what if I average all the data points and then show it in one row? That is wrong thing to do. If you average out, you are missing out. And you are missing out on important factors, important variations. So, I would suggest don't average out. Right? So, how to organize the data? So there are 34 sensors, right? 34 sensors, 17 one hand and 17 the other hand. Right? So there are 34 sensors. how you arrange is like this. So action 1, so action, the moment I say action 1, that means it's one instance of the above gesture. Right? So action 1, person 1. Action 1, person 1. You can arrange it as accelerometer X, accelerometer Y, accelerometer Z, orientation, and you don't have to follow this order. You can have different order. But have those all, maybe this is right hand. Right hand. Have all 17 of right hand, then all 17 of left hand. Right? This is for a single action, single person. Append all 20 instance, all 20 actions of that person. Then append different person. So in the end you will have how many rows? You will have 20 actions, right? 20 or 10 actions. No, 20 actions. 20 actions of 10 gestures of 39 or 36 or how many people? 37. These many and multiplied by 34. These many rows. Right? You will have these many rows. So these 20, these are actions. These 10 are gestures. These 37 are people. And this 34 is sensors. Right? Pretty simple thing to do, 5 minutes in MATLAB. Now, why now on the row, on the column is what? Column you have all the instances over time. So how many instances do you have? You should have 35 to 45 samples. Should have 35 to 45 samples. Why? Because the data is collected at 15 Hertz and each action is supposed to last only 3 seconds. Now you find some bad apples here. You will see that, okay, first of all, why 35 to 45? Why not just 45? No, actually 35 to 55. Why not exactly 45? Because there is some synchronization issues. Somebody cut off a little bit early, somebody cut off a little bit late. So varies like this. But you will find some bad apples in between them. You will find some big data points. So 70, 80 samples. Delete them. Those are bad. Delete them. Ignore those data points. But if you have 35, then you need to make it maximum. So let's say our maximum is 55. Use 0 band. Just add zeros to make it 55. So this you have for about. This you generate for other gestures all 10. Oh, mistake. This 10 gestures, yeah, I mean you can have it in one file, that's fine. You can have it in one file, 10 gestures, or you can choose to have 10 different CSV files. That's fine too. I would suggest have 10 different CSV files. That's better. That's better to have 10 different CSV files. So in this case, you will have just one row. Not one row. 20 multiplied by 1 multiplied by 37 multiplied by 34, these many rows. And you will have 10 CSV files. Okay. Yes?
When you said delete the extra parts where there's 70 or 80.
No, delete the entire
Delete the
data.
whole.
Delete the whole row. Now if you delete the whole row, don't just delete that particular sensor, delete the entire person's data. That's what I'm saying. Now, the thing is, a lot of people are saying that okay, analyzing on 37 people is becoming too tedious. Don't have to do it. If it's tedious, don't do it. But don't focus on one. Right? So, at least take 10. You don't have to take all 37. Take 10, that's fine too. But don't just focus on one. Right? Why I am saying is that because of the next phase. In the next phase, you look at the data and figure out features. Right? Now, if you just focus on one person, that person might be wrong, might have done some weird hand movements. Right? So, if you see 10 people and if you see consistent patterns in 10 people, then good, then you can use those as features. That's why I say that don't just focus on one. Maybe at least 5 you should do. 5 is a must. If you can go to 10, that's great. And if you can go 37, that's A+. Now the thing is, if you go 37 and you put all 37 in the report, then B-. So only put interesting ones. Right? Because your report has to be constrained, it cannot be 100 pages. I should be able to read it maybe in 3 hours. I cannot read 100 pages in 3 hours. Right? So make it short. Why? You only show the interesting ones. You don't have to show graphs for all 37 people, all 34 sensors, all 20 instances. Right? You can draw average graphs, or you can just show the interesting, the most varying sensor, or the most varying feature. Right? So while plotting, you keep that in mind. Then the next task was what? Next task, task 2, is telling you to extract features. So how will you extract features? So the first step is to plot the signals. Yes, you had a question.
Should we like always right followed by left?
You can do left followed by right.
No.
Just write about it.
Actually, in the file it is like for accelerometer right left and then orientation right left.
You can do that as well. There's no error.
Can it be
As long as you can identify that this is right, this is right.
Okay, can it be transposed in this way, like column wise instead of row wise?
It will make it difficult to
Because
see.
the data is already in column wise, so we just appended it below. It is
No, you will append it below.
no here it will be no. The accelerometer data is set in this column. It's not like this.
To make it this, what do you do?
No, is it like good to do only in this way or like?
There's nothing good. So you can do the other way
That
also.
way also.
Yeah. Just make sure that you write about it and I am looking at it the right way. Okay, now features. So how will you get features? So the way to get features is first plot. Just look at the data. You have to look at the data. Now do you look at all 34 sensors? No. Look at the actions. About is what? What do you do about? How do you do it? Like this, right? So you know that this is stationary, the left hand, so dominant hand, right hand is moving. And it's not, the accelerometer is not going to give you much results because there is no acceleration. The hand is kind of stationary. But orientation, right? So right at the, right before even looking at the data, you know that I don't want to see that accelerometer, I don't want to see EMG because there is no movement, there is no grasping, there is no muscle movement, there is just one finger going around. EMG don't care about EMG, right? So remove EMG, remove accelerometer, gyroscope also not there because there is nothing like this or nothing like this, right? It's just this. So look at orientation. So that's how you can eliminate, by reasoning about the gestures. You have the video, right? You look at the video. Yes.
But in that way, you can't code for every gesture. Your code is
Yes.
not general. It's
No, yeah, exactly. Your code won't be general for every sensor because for each, for every gesture. For one gesture, you have to choose which features I am going to take. Yes, exactly.
It is like
Or you can make it general. Wait, one more. You can make it general this way, that you select specific features for specific gestures, then combine them. Just have all of them.
Here you have only 10, so you can do it. But in real world, you have many words, so you
Oh
can't.
yeah, we are not solving a real world problem. It's just the assignment for now. Yes.
But if we eliminate some sensors, what after this? We will be using some classifier on this, right? So you can give data of different sensor in same feature vector to a classifier to just classify it. Like we need to have like common feature vector.
Oh yeah, that's what I am saying, that you combine all of them, then you will have common.
That could be a union on that.
Union, yes.
So it can be all of them.
It can be all of them, yeah. It can be all of them, but then you are not looking at all of them. You don't have to look at all of them, right? The machine can do all of them. Machine doesn't care about work, right? But you are not looking at all of them. So, but if you can look at all of them, that's great. Look at them. Right? So that is the intuition part. That is the intuition part. And you show me the intuition using the graphs. You say that, okay, say my intuition is that this hand orientation should be good. So you plot the orientation for this hand for about gesture and show that, okay, it's sinusoid. So yes, that action is there. And don't plot for all 37 people, plot average. Or maybe plot 5, overlap. Show that, okay, all 5 see this hand has sinusoid. So that is a good feature. So that's how you argue about feature. Right? So that is the first part of the second task. The second part, okay, is how to extract that feature. Now in there you have to apply some feature extraction algorithm. So you have to see, you are seeing some feature. How do you make the computer see it? So this feature, the sinusoid, how do you make computer see it? Take a 50 and get the dominant frequency. That is your feature extraction algorithm. Right? Or let's say you figured out a weird shape. Let's say 2 humps. How do you get it? Do DWT. And take maybe the 3rd or 4th level DWT. DWT is basically what? Discrete wavelet transform. How many of you know that? How many of you know discrete wavelet transform? Why? You don't know? Okay. I thought a lot of people should know. So, you know ECG, heart signals, how it looks like? Right? These are characteristic humps. This is called P, this is Q wave, this is R wave, this is S, and this is T wave. Right? These don't look like sinusoid, but these are waves. How do you extract them? If you do FFT, you will see a lot of frequencies because these are not sinusoid. Right? So how will you extract these characteristics? One way is to do DWT. What does DWT do? It's a series of filters, low pass, high pass filters. Right? So what you do is you take the signal ST and you apply a low pass filter and a high pass filter. So you have one cutoff frequency F1, and you do a low pass at that cutoff and you do a high pass at that cutoff. That low pass goes. You take the high pass, select a second frequency, low pass, high pass. This low pass is gone. You take the high pass, select another third frequency. Now how you select frequency depends on what DWT you are doing. There are different types of DWT. For example, and you have to use different types of wavelets. If you use different types of wavelets, then these frequencies are automatically computed. What are wavelets? These are like shapes. So this is a Mexican hat wavelet. This is a R wavelet. And these are different shapes. So basically, conceptually, what it is doing is trying to extract the shape from this signal. Extract this shape from this signal. Right? That's what it's trying to do. But yeah, you give it a wavelet and then again do low pass, high pass, and you do it for 3 to 4 levels. So this first level, the second, third, and do it again another. Take the third and fourth level because first and second level are typically noise. So you don't need to take that. Take the third and fourth level and look at these low pass filter results. These are the DWT coefficients. These can be features. So if you pass an ECG through this, you will see that this output is like it's like this. Oh no, actually no. The peaks are sharpened, right? The peaks are sharpened, so you get a sparse signal with non-zero values right at the positions where there are peaks. So you just take those positions. Those positions can be your coefficients, or I mean features, right? Yes.
These are latent features?
No, these are blatant ones.
No, like,
You can just see them.
how do I name it? Is it?
It's just features. Oh, why do you want to name it latent?
No, feature in the sense, is it accelerometer, right hand gesture, or it is?
So you can do that on anything you want. So let's say you said that, okay, my right hand orientation has this feature, I want to extract it. Right? So then you do it only on right hand orientation. Right? You just do on right hand orientation and get this data.
It means like if the graph comes like this, it means there is a variation in right hand
Yes,
orientation.
and then you do feature extraction on that sensor. So you don't blindly do a feature extraction on everything. So when do you do feature extraction? When you see the feature, then only you do feature extraction. If you cannot see it, you cannot extract it. As simple as that. Even if you use machine learning, since the people say, right, the CNN we use it automatically extracts feature. It cannot extract features that we cannot see. It only extracts features we can see. Right? So you have to guide it, you have to tell it. So CNN only gets convolutional features, right? How did it come up with convolutional features? Because we know that visual features can be extracted by doing convolutional matrices. Can it come up with features that cannot be extracted using convolution? It cannot. Right? So we can extract features only the ones we see. We cannot extract features that we cannot see. So you see it and then you apply a feature extraction algorithm. It is only for the computer to understand what you see. That's the purpose of feature extraction algorithm, apart from dimension regression and all that. So you do feature extraction, but then you have to make a feature matrix. You have to make a feature matrix, because unless you do that, you cannot go to PCA. So that is the third task. The third task is first you have to make a feature matrix. Now how do you make a feature matrix? From this data matrix, how do you make a feature matrix? Let's say you said, okay, I want FFT of accelerometer R. So from this, using the about, for the about gesture, let's say you figured out that, okay, no, orientation R is important, right? And I need to do DWT of orientation R. And maybe accelerometer L is important because it has to stay stable. Right? It shouldn't move much. So what I did was, here is accelerometer Z left. I took a differentiation. I took a differentiation of accelerometer Z. What should it be if it is stable? Should be 0. Right. So I should get all zeros here. So I take differentiation and then sum it up. It should be 0. So that is another feature. So I took those features. Now how do you make a feature matrix? So let's make a feature matrix. Now remember, this what I am saying you don't have to follow. You can do your own thing. Just explain. There is one way to do it. This might not be the best way. This might not be the correct way. So you figure it out. Now this might be daunting because there is no correct answer and you're trying to do coding and arguing. But see how it goes. Let's see. If it becomes too daunting, then from the next class I will make it simpler. You will be my guinea pigs.
So, you expect the differentiation to be 0, but if it is not 0,
It may not be.
yeah, so can I discard that?
No,
Discard that?
no, you cannot discard it. If it's not 0, then that means there is something either wrong with the person doing the gesture, or it is wrong with your arguments.
No, like, okay, for about the left hand is...
The PCA will tell you.
No, left hand is going to be constant, and if I get some values out of it, that means it's actually...
No, right now you don't discard. That's what I'm saying. The PCA will tell you to discard.
So
Right.
we do task 3 and then we do task 2.
But
We do task 3 and then we do task 2.
no, you first do task 2. And then task 3 will tell you, okay, no, this was not, your choice was not good. Right? And you don't make another choice. Your choice was not good, well, I cannot do it again. Yes.
So for task 2, you have your intuition and you get like orientation is major feature for about. So when we do feature extraction, if we consider all the sensors only, then when we get the extracted features, we can say, right, we can support that our intuition was correct.
Feature extraction is not there for your intuition to be correct. Feature extraction's purpose is that you have seen some feature, how do I make the computer understand it? Right? So that doesn't say anything about whether my feature extraction intuition was correct or not. That doesn't say anything about it. It just says that I have some intuition, can I make the computer understand that intuition? That is the only purpose of feature extraction.
So what we visually understand, we make it understand. We make the computer understand.
Computer understand. Yes, exactly. Yeah.
Comes to TWT, there we were trying to recognize the patterns within the signal, right? Which is the specific shapes within the signal.
Okay, now in 3, task 3 will tell us whether our intuition is correct or not. Right? So in order to have task 3, you have to have a feature matrix. So how do you do feature matrix? So again, let's say, okay, for about gesture, I know that orientation R, DWT is important, accelerometer ZL, differentiation is important. So how do I do it? So what I will do is, again, you generate separate feature matrices for separate gestures. So about gesture, let's take the about gesture. So for action 1, person 1, what you do is you take one huge row. You take DWT of orientation R, let's say there are 5 different points. Our output is of length 5. So you append. So this whole thing is DWT of accelerometer R. Right? Then you have differentiation of accelerometer ZL, maybe 6 points or 15 points. So this is accelerometer Z left. Right? Now, this is action 1, person 1. Do it for action 2. No, action 2, person 1. Same thing, don't change. Don't change the features that you have selected for this particular gesture. Do it on all actions of all persons together. Right? Don't be person specific, don't be action specific. Be gesture specific. So for a gesture you have said that the DWT of accelerometer R is fine, accelerometer Z left is fine, differentiation of it. Have it for all actions, all people. So now you will have a huge matrix which is 20 multiplied by 37. These many rows. Right? These many rows, how many columns? Depends upon you. I don't know how many columns.
And it varies for gesture also.
It varies for gestures. Yes. Now you have a feature matrix.
Is this same feature DWT repeated 5 times? Or
DWT will give you, it won't give you just one data. It will give you a array as output.
so it's the same sensors.
Yeah, accelerometer are DWT.
So is it like limited to 2 or 3 or
What 2 or 3?
the accelerometer DWT and orientations FFT if I'm taking so is it limited to 2, 3 or I can take 4, 5?
You can take 4, 5, 10, 11, however many you want.
But it should be less than the 34 sensors.
No, why? It can be more. It can be 70. That doesn't matter. So it can be 70, 100, 20, 20,000, I don't care about that. However you need, however many you need. Yes.
You mean to say to apply the same feature extraction on every person doing every sign? And
Not
then-
every sign. For that particular about gesture, every action of it. you're doing. Now this can change for different gestures. For different gestures you might have different type of features.
To find out that DWT is good for this particular about, do you consider this one act, all 20 to 37 actions for about, or just like?
And you don't have to consider all 20, 37. Ideally you should, but don't have to consider. So maybe you take 5 people and 2 or 3 actions out of it.
Just so that it's consistent.
Yes, consistent with some confidence. Don't just see one.
If we do PC on this one, each sensor will show the maximum variance.
Okay, so that will come to that. But you understand this, right?
How do you use it for classification in the next phase? Like, because,
That's for next phase.
because features will be different for each gesture, right?
Yes, so you have to combine. That will worry in the next phase.
Okay.
Don't worry too much. So now you give this data matrix to PCA. What will PCA do? It will find the covariance, right? Covariance matrix of this, and it will find out eigenvectors, which has good eigenvalues. And it will also arrange the eigenvectors that have maximum eigenvalues. So it might, in the order of eigenvalues, it will arrange. So you get a matrix. The output of PCA will be a matrix. It will have eigenvectors on these rows, V1, V1, V2, V3, and V1 has the highest eigenvalue, V2 has the next highest, V3 has the next highest, and so on. Right? And then it will also have V11, V12, V1n, V21, V22, V2n, right? Coefficients. It will also have coefficients. This is your eigenvector matrix. You multiply that with the data feature matrix. So now if you multiply with feature matrix, what is happening? So just take the first row of the feature matrix and take the first column of this eigenvalue matrix. So for first row is what? DWT of accelerometer right hand 1, DWT accelerometer right hand 2, DWT accelerometer right hand 3, and so on. However many DWT you choose, I don't know. And then it will have differentiation of accelerometer Z1, differentiation of accelerometer Z2, however many you choose. Then it might have some other features, I don't know. So this is one, the first row. Take the first column. If you multiply this, that becomes your new features, right? New feature matrix. So when you multiply this, what is happening? You are basically taking a weighted average. So you are taking, okay, V11 DA1R plus V12 dA2R plus V13 dA3R and so on, right? So that is the first feature in the transformed feature space. That is the first feature. What are these? These are importances of these features, right? So if this is very high and these are 0, then it's saying that, okay, the first DWT component of right hand of accelerometer X is very important. Now you go back and argue, okay, why is that important? Does it satisfy my initial intuition? It might also be that, okay, no, not just the first, maybe the second, third, all three are important. Then you argue, okay, why did it say that? You had accelerometer Z. It says, maybe the PCA says, okay, accelerometer Z is very important. But you know that accelerometer Z of left hand is not important. Why is it saying it is very important? You know that differentiation has to be 0, so the variance has to be very low, right? But why is PCA saying that it is very important?
It would be very important that it's 0.
No. If it is 0, the variance is going to be 0 also. So if the variance is non-zero, then that means there is something going on with accelerometer Z, it's not stable. It might tell you that accelerometer Z is very important. The reason is, every action you are doing, you are starting from here, moving up. Starting from here, moving up. So accelerometer 0, Z will have a lot of values before it becomes stable. You're moving up and also moving down. So these kind of things you have to argue. So PCA telling you that something is important doesn't immediately mean that your intuition is wrong. You have to still think that why is PCA telling me? Maybe my intuition is wrong, or maybe I am not counting for some artifact in the data. So just give that argument. That's it. Yes?
So what if you choose wrong features in the task 2?
That's fine. You choose wrong, so you won't be penalized for it.
No, but if it says some correlation in this one, will it be like true if you choose some wrong?
May not be, right? Because maybe maximum variance is good, maybe maximum variance is not good.
Should this make sense why we are choosing it?
Now, so the thing is, the PCA, we are just using one technique, right? PCA. PCA is not the gospel truth, or it's not the best possible machine learning or feature dimensionality reduction algorithm in the world. It just looks at maximum variance, and that maximum variance may not be due to a very interesting fact. It might be just noise in the data, right? So even if PCA says that your intuition is wrong, it might not be wrong, right? So even if it says wrong, you don't stop there. Just keep continuing. So, do you have any questions? That is the, okay, no, the thing is, now you focus on report. Report is very important. Because if I just run the code, it will work. Everybody's code works. Because that's how you generate code graphs. But that doesn't tell me anything. So I will read the report very thoroughly. If you don't write report logically, then you are going to lose points. One thing is, you have to have a very clear explanation. Just arguing about your intuition is enough. And you have to argue about your intuition from the knowledge that you have gathered while taking the data collection. You had some experience with data collection, right? So you have to just tie it up to that knowledge. That is one thing. And then the algorithms that you are describing, you are using, be very specific in those algorithms. Exactly how are you calculating FFT? What input is it? How many points of FFT are you doing? So look up the algorithm a little bit. Don't just use FFT MATLAB, right? Just see what is FFT doing. MATLAB uses the DFT mechanism, right? Butterfly mechanism of computing FFT. Now that butterfly mechanism only works on data that is size of 2 to the power x, but you don't have data that is 2 to the power x. So how is how will FFT work? Still gives you results, right? How will it work? So underlying it is doing something. It is either repeating the data twice, or it is zero padding, or it is deleting some data points. It is doing something, or resampling it, right? And then subsampling. So just doing FFT doesn't cut it. You have to say, okay, how many data points did you put as input to the FFT? How many points FFT did you do? What are the major frequencies? Right? All those explanations you have to give me. And be very careful about graphs. Then what else? Don't write too much. I think that's it. So if you have any questions, I can answer. Or we'll go into the clustering discussion. Yes, you go.
I was going to ask, when do we think we'll know about our tests?
Test this week. They have already started grading. Long time back actually. Yes, you had a question?
For the task 2, according to you, we can use different feature extraction methods for different gestures?
Yes.
So when you say in the question that you should use at least 5 feature extraction methods, what does that mean?
So you should try out at least 5. All 5 won't work for all the gestures.
So it's possible that we apply only one feature extraction method.
Yeah.
One
Yeah.
gesture.
Any other questions? Okay, so let's discuss. Okay. Yeah.
Please complete that new feature dimension. How will transform it to new feature dimension?
Just multiply.
Okay. How will we remap it to the version feature?
You already have it. You don't have to remap.
For example, feature 47. For example, I know
Feature what?
in the feature matrix, I know feature 47 is the EMG radar and the effective transformation. But after multiplying with the icon vector, I don't know which feature it represents.
Yeah, but you know the values of the eigenvector, the components of the eigenvector. Each component is the coefficient of that particular. So the first component is the coefficient of the first feature. The second component is the coefficient of the second feature, and so on. So you know how you are combining different features.
So the first eigenvector is enough for you to...
No. First eigenvector is one feature. The second eigenvector is the second feature.
To find out the coefficient, to find out if this particular feature is important, just the principal component is enough, right?
Look at 2, 3. 3 maybe maximum. 3 principal components. Yeah.
The order of the feature matrix matters.
The eigenvectors will reorder themselves. Any other questions? Okay, so I will put the deadline to 19th and then let's see what happens. And I'll post the third assignment today. I'll post the third assignment today. So if anybody is done, they can start working on it. Now let's go to clustering. Actually, this chapter is, clustering is pretty boring chapter. But let's see, because we need to know clustering. So last time we discussed k-means and we saw some examples, and we said that the problem is that the k-means suffer from initialization, right? Different initializations can lead to different clusters. And we don't want that, we want a consistent result. So we said that, okay, one way to evaluate clusters, evaluate how good a cluster is to compute this SSE, the sum of square error. right? That is one way. Now, what does this SSC do? This says that okay, it's distance squared, median versus x, right? And you sum it over all the elements inside the cluster and sum it over all the clusters. So, what is the best SSC that you can get? 0. Right? If each data has its own cluster, 0. So the aim of SSE is to minimize the intra-cluster distance. I always confuse between the two, inter, I forget. It's intra, right? In intra-cluster, so within cluster distance. Minimize the within cluster distance. But it doesn't say anything about the inter-cluster distance, in between clusters. So that's why SSE is only used as a evaluation mechanism for clusters. It's never used as an objective function. Because you wouldn't want to minimize SSE. But you would want to choose clusters that have lower SSEs. So minimizing SSE will lead to this situation that each data point becomes one cluster. That is not useful for us. So we are saying that okay, there is a problem of selecting initial points. One way to solve this is bisecting k-means. So that is where we stopped. So let's talk about bisecting k-means. Very simple idea. You take a large data point, and initially you just do 2 clusters. You use k-means. You use k-means to divide it into 2 clusters. Then maybe take the largest cluster, and again divide it into 2 clusters. Then take the largest among the 3. Right? For initially you have 1 big cluster, then you have 2. Then you took the largest cluster, divided that into 2, so you have 3. Now take the largest among those 3, divide it into 2, you have 4. Take the largest, divide 2, so on, go on, until you reach k. Why is that good? It's good because each time you are taking 2 clusters. So you only have to guess 2 initial points, not k initial points. So it reduces your probability of choosing wrong initial points. It's hard to make 2 initial points go into totally bad areas. Rather, it's very easy to make at least one of k initial points to go into the wrong area. Right? So it helps you bisecting k-means. So now what people have suggested that you use bisecting k-means, you get k centroids using bisecting k-means, and then you use that as initial centroids for k-means. Right? And do k-means again. So that will result in better clusters. So often what people do is that instead of just bisecting it once at each step, you take one cluster and you divide it into 2, right? So instead of doing it once, you do it 3-4 times. Take the same cluster, divide it into 2, 3-4 times. So you have 3-4 initial points. Just take the top 2 clusters. Top 2 clusters means top 2 clusters with the highest SSE or lowest SSE. Right? 2 clusters with the lowest SSE, take those. So you can do some averaging there also. So that is what this algorithm says. So initialize list of clusters to contain cluster consisting of all points. Then take one cluster, divide into, perform several trial bisections. Trial bisections means you select initial points, bisect, initial points, bisect. Let's say you did 10 times. Then just select the top 2. Top 2 means ones with the lowest SSE. Right? And then you go ahead and you continue doing it until you have k clusters. So this is an example that they are showing. So initially you had these 2. Right? And then so now which cluster do you choose? Now which cluster do you choose to bisect? There are 2 options. One is you can choose the cluster which is the biggest, or you can choose the cluster which has the highest SSE because you want to reduce it. Right? Or you can choose the cluster following certain certain algorithms. You can have some optimization objectives, right? So here they have chosen to select the largest cluster. So they select and divide it into two. Now select another cluster, this one divide into two. Select this is divided into two, and it goes like this. Okay. Finally, in iteration 10, by shifting k-means finds all the clusters. Very good. So k means strength and weaknesses. Yeah, the algorithm is pretty simple. It's very easy to implement, right? But the problem with this algorithm is that initial points is a big problem. But another thing is that it can only work for globular structures with uniform density. So globular structures means balls. You have to have the clusters look like balls. And also the density has to be uniform. You cannot vary the density. If you vary the density, then it goes mad. So K means has those two problems. So if you look at different sizes, also K means has to work on clusters of similar sizes. If there are different sizes, then it has problems. So that's what they are showing. If you have different size original points, then 3 clusters, if you have, then it's totally wrong clusters. And not wrong clusters, it's visually not appealing clusters. And we don't know whether it's wrong or right, because it is unsupervised. Again, if you have different densities, so the blue and the green have higher density, but the red has different density, then 3 clustering goes wrong. Right? K equals 3, 3 means cluster. It is wrong. Wrong means not visually appealing again. And then it cannot do non-globular shapes. Here, if you have to K equals 2, it will give you some weird results. So what can you do? You can have different techniques. So one thing is called hierarchical clustering, and then the other one is density-based clustering. So we'll talk about these two. So hierarchical clustering means what? There are 2 ways of hierarchical clustering. So 2 ways. So first way is you consider that every data point is a cluster, and then you merge clusters. So bottom up. Right? Every data point is a cluster. You merge clusters until you have k clusters. And then there is top down. You consider that you have only one cluster, and all data points are in that cluster. Then you divide it until you reach k. So this is called agglomerative or divisive. So agglomerative means you start with points as individual clusters, and at each step merge the closest pair of points, right, and make it clusters. So closest pair of clusters, right? And divisive means start with one all-inclusive cluster, and at each step split the cluster until only singleton clusters of individual points remain. In this case, you might decide to just stop at the middle somewhere. Now you notice that if we look at agglomerative clustering, you have to define distances between clusters, not just distances between points. So how do we define distances between clusters? So which means that you have to define distances between sets. Right? So there are many ways. There are many ways to define distances between sets. One is Hausdorff distance. Have you heard of Hausdorff distance? No? He has heard of it. So it's there are a lot of distances where you can come up with a distance with your name in it. But Hausdorff distance looks at the shape of a set, and it tries to find out the minimum or no, actually infimum, but let's say minimum point that is closest to a particular set. So it is a difference between minimum point of one set and a maximum point of the other set. So that is, they don't use it. They use some single link and multi-link or something. So this we have already understood, dendrons, right? Dendrogram. Dendrogram we have talked about. So let's skip it. We have already talked about it. You say, so this is agglomerative clustering algorithm. So what is the basic algorithm? That says that, okay, first you have to compute the proximity matrix. So you have to define distance between clusters and figure out what is the proximity matrix. And let each data point be a cluster. And so each data point is cluster first. Then merge the two closest clusters, update the proximity matrix until only a single cluster remains. And then you can stop in the middle. So key computation is the proximity of two clusters. So there are different approaches to find out proximity. So let's show an example, but before an example, let's look at this. So let's look at different definitions of proximity. So there is the min proximity, max, group average, and then there is single link and complete link. So let's look at those. So min defines cluster proximity as the proximity between the closest 2 points that are in different clusters. The closest 2 points that are in different clusters. So what you will do is you will you have to do if set 1, if cluster 1 has n items and cluster 2 has m items, you have to do nm comparisons and figure out which ones are the closest. So that is minimum. What is maximum is it takes the proximity between the farthest 2 points in different clusters to be the cluster proximity. So farthest 2 points. Same, nm complexity, you figure out the farthest. Or you can do group average. Again, nm complexity, do average, sum it up and divide by nm. Now if our proximities are distances, then the names okay, but anyways, so min max are also called single link and complete link. The min max. So if we look at this, then how will we use it? So initially we have all these, these are P1, P2, P3, P4, P5, these points. Now what is the mean? The mean are these closest points, right? What is the max? The max is this farthest point. Group average is you do all possible connections and figure out the average. And distance between centroid is another way. And then you can have some objective function also. Okay. So let's figure out this one. This is an example. It's 6 2D points and see how the clustering is done. So these are the points, the x and y coordinate, and this is the Euclidean distance matrix initially given. Right? Now what will you do? You will find the closest points. So what are the closest points? You will figure out the minimum here. Where is it? This one, right? No, this one.
No. Yeah.
P3, P6. Right? So you merge them. So next one becomes okay. P3, P6 is this. Then what is P5? Okay, we have to do it on paper. It's much easier on pen and paper. So let's say P1, let me just copy it and then I'll show it to you. I'm doing too big. So I'm only doing the upper diagonal because it's all going to be the same. Okay. So you have this, then you say that this one is smallest, which is P3, P6. So now you have to update and you have to make a cluster. Right? So P3, P6. So now instead of P1, P2, P3, you will have P3, P6. And then you will have P4, P5. And same here, P1, P2, P3, P3, P6, right? P4, P5. Right? Now you compute, this remains the same, this also remains the same, P1, P2 remains the same, so 0.24, right? This one should change. Right? Now let's say we are using mean. Right? Let's say we are using mean. So P3, P6, what is the difference distance between P1 and P3, P6? How will we figure out mean? So we will have to figure out P1 and P3 and P1 and P6. Right? Which one is closest? 0.22. Right? So we put 0.22 here. Is a distance, right? Yeah, so that is fine. So then P1 and P4 remains the same. 0.3. Oh, there is a P6. Oh, there is no P6. 0.37. And P1 and P5 remains the same. 0.34. Right. Then P2. What is the minimum? What is the distance between P2 and P3, P6? So you say P2 and P3 is 0.15. P2 and P6 is 0.25. So take the minimum. 0.15. P2, P4 remains the same, which is 0.2 and 5.14. Right. Then again P3, P6 with P3, P6 is 0. Right. P3, P6 versus P3, versus P4. So which one? So you take P4. This is P4. What is the distance between 3? P3 and P4 is 0.15. And P4 and P6 is 0.22. So you keep 0.15. Then P5 and P3, P6. So 0.39 and 0.28. So keep 0.28. And P5, P4 remains the same. Yeah. Now which one will you choose to merge? Now you choose P2, P5. Right? So go ahead like this. Simple. So that is your agglomerative cluster. And that is what this example is showing you, and how it shows you, I don't know. So now how will you represent that clustering using dendrograms? So you say that initially P3, P6 were merged, so merge them. Then 2 and 5 were merged them. Then turns out that these two were merged them. Then these two were merged with 4 and with 1. So that shows the dendrogram and shows how the clusters were developed. Okay. Yeah, it's a nice animation. Now this will change if these were similarity measures. If these were similarity measures, instead of taking mean, you have to take maximum similarity. Okay? So you have to see whether we are using dissimilarity measure or similarity measure. So the answer will vary based on that. So it shows another max algorithm. Group average you can do. I am not going over these examples again. So based on what you choose, you will have different results. Now, what are the strengths? So strengths of min is that it can handle non-elliptical shapes, and the problem with min is that if the shapes are overlapped, then it becomes a problem for min. On the other hand, max is if the shapes are overlapped, then it can push them apart. But if the problem with max is that if you have different size clusters, then it will have problems. So you can combine the different algorithms, min, max, and group average. You can combine them. So these are some time and space requirements. These are not really important for discussion. I will just go on to density-based clustering algorithm, but in the next class. And density-based clustering algorithm will finish it. That should be the end. Yeah. So we will finish clustering next class.